Tutorial 1, Part 5, Material Classification, Structures and Properties. This part is the most important part in this tutorial, and we will try to introduce some general types of materials and try to explain some general material properties by the bondings of atoms and molecules within these materials. In engineering, we classified all materials in the following 4 categories. Metals consists of all the metals, such as ferrous metals, iron, carbon steels, and some alloys, and such as brass and etc. Ceramics includes glass, ceramic, graphite, and diamonds, and etc. Polymers include some plastics, such as thermoplastics and thermoset plastics. Between them, if the material is consists of more than one metals, more than one type of materials, for example, if this consists of metals and polymers, we call it composite. If this consists of both metals and ceramic, we also call it composites. For example, concrete consists of ceramic and metal. Reinforced plastic consists of plastic and metal, etc. And we call it composite. Metals, as its name suggests, that the atoms inside the metals are bonded by metallic bond, and their structure is giant metallic structure. As one thing is, metallic bonds are non-directional and extend throughout the solid. And there is some example: iron and sodium, etc. Property of metals: shiny. They are shiny and they have a good thermal or electric conductivity. It is because there is free electrons between metal ions. Second, they are generally hard and have a high boiling point. It is because metallic points are strong and they are throughout the full solid. They make the complete breaking of metallic bonds very difficult, because boiling requires the complete breaking of metallic bonds. And they are also very ductile, because sliding of metal ions are easily done without complete breaking or non-directional metallic bonds, as shown in this picture. There is still metallic bonds after the deformation, which can be formed between 2 pieces of metals. Structures of ceramics: they are basically giant covalent or giant ionic, or in between them, if you still remember ionic characteristics. Ionic and covalent bonds are extended throughout the solids. For example, aluminum oxide, they have a bonding of partially ionic and partially covalent, and you can see here it is extended throughout the solid and connect every single atoms or ions within this piece of solids. Diamond, it is completely giant covalent, and all of their atoms are carbon. And there is a special example. It is also ceramic, but it is somehow different from other two. Graphite, it is completely giant covalent, and all atoms here are carbon, but it has a different structure with diamond. You can see here. For diamond, the bondings extend throughout the solid. But for graphite, the covalent bond will extend only for a single layer, and between layer and layer, they are connected by a secondary bonding, and they are connected by forces, those dispersion forces. Ceramics have a poor electric or heat conductivity. It is because there is no free electrons, as all electrons are localized by atoms or ions. Second, they are very hard and have a very high melting or boiling points. It is because there is strong covalent or ionic bonds throughout the whole solid, and which requires complete breaking. And it is even higher than the bonding is even stronger than those metallic bonds. However, it is very brittle because sliding of atoms requires breaking of directional covalent bonds. The sliding of ions will also break ionic bonds. For example, for this piece of ionic materials, when we try to deform it, just deform it by little, it can already deform the regular shape, regular arrangement of those ions. And even a very slightly change of the locations will result in a repulsion force due to the light charge. And that means it is very brittle, unlike those metals. For graphite, it is quite special. The first thing, it can conduct electricity because it do have 3 electrons in carbon layers. For each carbon atoms in a single layer, they are bound to 3 single covalent bonds. But there is still one valence electrons, which is 3. And it has a high melting and boiling point, which is the reason is same with the ceramics. And there is strong covalent bond throughout the layers of the solid. You still needs a complete breaking. But it is soft and brittle because the layers of carbons are bound by dispersion forces, which is here, and which is very weak, and which allows the easy sliding of carbon layer, which means that it is very soft. In terms of polymers, it consists of very long molecules, which we call macromolecules, and the intermolecular forces are produced by our secondary bondings. There is several different kinds of arrangements of these very long molecules. For example, linear, branches, or cross-linked. And those very long molecules are actually bound by some single small molecules, or before the polymerization. Polymerization is the forming of those very long molecules. They consist of all monomers, or in other terms, those small single molecules. After some reactions, they form those macromolecules, which is very long and self-repeating. Some properties of polymers. They have a very poor electric or heat conductivity, as there is no free electrons, and those electrons are localized by atoms and ions. Second, they have a very low melting points, and they are generally softer because intermolecular forces are weak and there is no primary bondings between molecules. And the third one is they can be very elastic due to the network structures of those macromolecules. Structures and properties of molecular substance. They are volatile, they are soft, and they have a very low melting and boiling points. It is because intermolecular bondings are covalent bond, but intermolecular forces are very weak. For example, ice and some non-metals, but excluding carbons and etc. As their molecules are very small, which can be compared to polymers, they will arrange in such way, and you can see that those forces between those molecules are basically just secondary bondings. And this proves the point for the first point, which is here. And therefore, this is such molecular substance or molecular solids are generally not good engineering materials. And I would like to add this part mainly for the completeness and the understanding of basic bondings and structures and their relations between each other.